Okay. Hello, Happy Face Health Club. Today we will be going through, actually this series is to take us through this book, A Graphical Approach to Algebra and Trigonometry. This is essentially a pre-calculus textbook, and my goal is to go through every chapter with review and worked problems. But before we go into the main contents of the book itself, we're actually going to review some basic algebra to prepare for that. So today will be a review of exponents and polynomials, and we're just going to jump right into some definitions and rules and examples, and this is really just to be a refresher before heading into more of the main algebra concepts. All right, so the first thing to recall is the product rule. So I will write that down. The product rule for algebra, not for calculus. And it is a raised to the m. So if you have any for all positive integers m and n and every real number a raised to the m and times a to the n equals a m plus n. So basically all it's saying is when you have the same bases and you're multiplying them by different exponents, you just add the exponents together. So here are some examples. No music, bud, thanks. So first one, let's say you have y to the 4th times y to the 7th, then your answer is going to be y to the 11th. So you just multiply the bases, add the exponents, and there's your answer. Here's one slightly more challenging, but still pretty easy. So you have 6z to the 5th, 9z to the 3rd, and 2z squared. First you can actually separate all of these, so you can separate the bases and the coefficients. Oh, that's my wife. Continue on. Also, she got me this amazing chalk that was originally made in Japan and now is made in South Korea, but it's like the best chalk ever. Just side note.
You're welcome!
Okay, so let's actually separate all the bases. Let's pull those out. So 6, 9, and 2. So 2. Yes, 2. And then separately you have z to the 5th. This is just to make it easy to see. Equals, so 6 times 9 is 54, times 2 is 108. And then if you have z, so 5 plus 3 is 8, plus 2 is 10. So you have z to the 10th, and just write it in simplified form, z, 108z to the 10th. So those are some examples for the product rule. Now we're going to go into zero exponents. So you also probably remember this, but any base raised to 0 is 1 unless the base is 0. So the rule is this: a raised to the 0 equals 1. 0 raised to the 0 is undefined. So some examples. A 4 to the 0, you guessed it, 1. Negative 4, B, negative 4, negative 4 to the 0, still 1. Here's a little trick question for you. 7r to the 0. If you just say 1, that is wrong, because we have to account for any situation when r might be 0. So we say 1 as long as r is not equal to 0. That would be the correct answer because you're accounting for the fact that 0 raised to the 0 is undefined, as we mentioned. All right, now erase. Now we're going to get into the power rules. Power rules. Okay, the first one. A raised to the m to the n is equal to a raised to the mn. Oh, there goes Senna. A, B, raised to the m. This is different. So this is saying this whole thing raised to the m. So it's going to be a to the m, b to the m. Okay, next rule. When you're dealing with a quotient, it's a over b raised to the m equals a to the m, b to the m. And we have to remember one thing too. This is always when b not equal to 0 because that would be dividing by 0, which would be undefined.
Right.
Okay. Right, buddy?
Yes.
Examples. First one, 5 raised to the 3 to the second. So that's like this right here. So we just have 5 to the 6th. Multiply the 3 and the 2, and then you're good. Okay, B. 3 to the 4th, x squared to the 3rd. Slightly more complicated, but still pretty easy. 3 to the 12th, x to the 6th. So just multiply 3 by 4 and 3 by 2, and you're good to go. C. 2 to the 5th over b to the 4th raised to the 3rd. You guessed it, 2 to the 15th over b to the 12th. But remember, b not equal to 0. And reminder, mn squared. So this is not equal to mn squared. So when mn is inside of the parentheses, you are squaring both the m and the n. In this, it's already defined, so it's just m times n squared. Totally different thing. And I'll just expand this just to show it a little bit more clearly. Would this be true? No, that would definitely not be true. So it's not equal. All right. Next up, we are going to talk about polynomials. Okay. So, what is... Actually, let's talk about what an algebraic expression is. So, what is algebra? It's basically any time that you are adding, subtracting, multiplying, dividing, finding roots or powers of any combination of a variable or a constant. So here are some examples of algebraic expressions. Algebraic expressions, e.g., example So this is an algebraic expression, 2x squared minus 3x. This is an algebraic expression, 5y over 2y minus 3. This is an algebraic expression, so the square root of m to the third minus 8. So those are just some examples of algebraic expressions. So whenever you have, we'll actually define what a term is. A term is the product of a real number and one or more variable. So if you have, let's say, terms, examples. So if you have 13x to the third, 4x to the third, and negative x to the third. These are all terms because there's a real number and a variable. And these are actually all like terms.
Bye.
Hey buddy, can you not stand by the tripod? Thank you. Yeah, don't touch it. Thank you. Okay. The next thing I'm going to also show you, these below, 6y, 6z, and 4y. Yeah. So 5x to the third plus 4, that's a polynomial. 5 plus 4, that is not a polynomial, that's just 9. Next thing, degree. We're just going through some terms here. The degree of a term is the exponent, it's the highest exponent, well, sorry, on a single term it's the exponent on the variable. So on x squared the degree is 2. The degree of a polynomial is the greatest degree of any term in the polynomial. So basically what that means is it's just the highest exponent of any term. So let's give 4x to the third minus 2x2 minus 3x plus 7. The degree is 3. 3 is the highest exponent that x is raised to. So we'll write the degree is 3. And let's see. I'm going to do a little bit of a grid here that I think is just a good drill for identifying, naming a polynomial and naming its degree. So the polynomial will be here, if I can write polynomial. The degree will be here. And the type, which is basically the name, will be right there. So here's the polynomial, 9p to the 7th minus 4p to the 3rd minus 8p squared. So 7 is the highest exponent that p is raised to, so we will say the degree is 7. And then this is named a trinomial, because there's 3 terms. So tri for 3, genius. Okay, next one, 29 x to the 11th plus 8x to the 15th. So 15 is the degree, and the type of polynomial is a binomial. Binomial for 2. Alright. This one is going to get pretty interesting. 10r to the 6th s to the 8th. This one actually, in this case, the degree is actually 6 plus 8, so it's 14. And this is a monomial because it's all just one term. So this is one term, and the combined, the exponents combined is 14. Okay, last one. 5, a to the 3, b to the 7th, minus 3, a to the 5th, b to the 5th, minus 4a squared, b to the 9th, minus a to the 10th. So what is the highest? So this is 10, this is 10, this is 11, this is 10, so it's 11. And there's no real name for this one, it's too big. None of these doesn't really have a name. Alright, next we are going to get to adding and subtracting polynomials. So just some examples. Adding and subtracting polynomials. Yay. Okay, some examples. I think in this case, just seeing examples is probably the best way to learn this stuff and just doing a bunch of problems. So here is the first problem. 2y to the 4th minus 3y squared plus 4. And it is being, not multiplied, we're adding, adding and subtracting. Plus 4y to the 4th, 7y squared, plus 6y. Alright, so you're just going to identify and combine like terms. So let's take a look. Okay, so we've got we have two terms that are y to the 4th, so 2y to the 4th, let's just, I'll do it this way. 2y to the 4th plus 4y to the 4th plus negative 3y squared plus 7y squared and 6y is standing alone, and so is 4. Okay, so we just combine these. So 6y to the 4th plus 4y squared plus 6y plus 4, that's a y. And there is your answer. Okay, let's do a subtraction one.
Sure.
For fun. Sound good? So negative 3m to the 3rd minus 8m squared plus 4 minus m to the 3rd plus 7m squared minus 3. Okay, with this one, when you have the negative sign in front of the terms over here, I actually like to distribute the negative in when I'm combining the terms. So let's do it. Negative 3m to the 3rd. Hey bud, can you stop with that plastic sound? Thank you. And then we're gonna go plus negative 8m squared minus 7m squared. And then we're going to do 4 plus 3. And then you're going to end up with 2m cubed minus 15m squared plus 7. Boom. Boom. Done. And I don't think I can squeeze the last one in, so I need to erase. Let's do one more, just to see how good we are at distributing. Is it still going, buddy? Okay, cool. Let's see, 4 x squared minus 3x plus 7 minus 5, 2x squared minus 8x minus 4. Alright, equals 4x squared minus 12x plus 28 minus 10x squared plus 40x plus 20. Okay, let's combine them all. So 4 minus 10x squared, negative 6x squared, negative 12x plus 40x, so that is 28x. And 28 plus 20 is 48. Boom, boom, boom. Alright, great. The next thing we're going to get into is multiplying polynomials. So there's a lot of techniques you may remember, foiling and such. So let's just do some examples. Multiplying. Are you still going? No? Okay. Alright. We ran out of memory. We're back. Multiplying polynomials. This is gonna be so fun. Alright. How do we want to do this? Okay, here's an example. 3x minus 4 multiplied by 2x squared minus 3x plus 5. So, I don't know, you can do this a variety of ways, but when I have less terms, or when I have a binomial and a trinomial, I like to split apart the binomial and multiply it through. It just feels like less work, but you know, it is what it is. So, here's what I'm gonna do. So, 2x squared multiplied by 3x minus 3x by 3x plus 5 times 3x, and then I'm going to go do that same thing over again, but just with the negative 4. So, plus 2x squared times negative 4 minus 3x, and then plus 5, negative 4. Alright. So that's the huge expanded term, or huge expanded linear combination of terms. So that is 6x cubed minus 9x squared plus 15x. Hey buds, can you stop that sound please? Minus, please stop the sound. Minus 8x squared plus 12x minus 20. Okay, so where are the like terms? Is there any other cube? No. So 6x cubed stays as it was. This is minus 17x squared. This is plus 27x minus 20. And there is your first example of multiplying polynomials. Okay. So what do you do if you have three trinomials together, it gets to be a pain. But we're going to do it anyway. So this is example A, this is example B. Let's see if we can save space. Okay, so this problem is 3p squared. Stop doing that, bud. Minus 4p plus 1 multiplied by p to the third plus 2p minus 8. Okay, so we're going to need a lot of room for this one. Okay, we're going to just do it the same way as I did above. So p to the third, 3p squared plus 2p times 3p squared minus 8 times 3p squared. Okay, you'll get the idea here. Plus p to the third. P to the third times negative 4p plus 2p times negative 4p plus minus 8 times negative 4p, and then we've got 1. So 1 times this is just this, so I'm just going to write this trinomial at the end. Plus p to the third plus 2p minus 8. So this is coming from multiplying 1 through, so it's just the same. Alright, now this is 3p to the fifth. This is 6p to the third. This is negative 24p squared. This is negative 4p to the fourth. This is negative 8p squared. This is 32p plus 32p plus p to the third plus 2p minus 8. Okay. I have a 5th degree. I have a 5. Is there any other 5? Okay, no. So 3. That looked ugly. 3p to the 5th. Cross that out. Is there another third? There is. Yes. 7p to the third. Cross those out so we know we're done. Oh. There's a 4th. Let's have the 4th be in there. Let's go minus 4p to the 4th plus 7p to the third. Okay. Then we have minus 32p squared. Where did that go? Right there. Plus 34p. Minus 8. Boom. Done. There you go. That's the whole thing. And that is how you multiply two trinomials together. Alright. Next thing. Foil. You may remember this from high school. First. Outside. Inside. Last. Or maybe if you're just like math prodigy, you knew this in middle school or younger, so I don't want to assume that you're that you had to wait till high school like me to know this. But let's do some examples. This is how to multiply two binomials together. So if you have 6m plus 1 times 4m minus 3. So this little acronym is telling you the order of the multiplication to do, or you can actually do you can also do FIOL, but you know, that doesn't really spell anything fancy. Let me check to see how the camera's doing here. Oh, 30 seconds. Hold on. Okay. We're back. Okay, here we go. So first you multiply first terms. So 6m times 4m, that is 24m squared outside. So 6m multiplied by -3 equals -18m. Yes? And then inside 1 times 4m, that is 4m plus. And then last, so 1 times -3 equals 24m squared minus 14m minus 3. Okay, let's do another. Here we go. B. 2x plus 7 and 2x minus 7. Oh, this is a special one because you'll see the inside, the O and the I, the outside and the inside, they'll cancel each other out. Okay, so first 2x times 2x, that is equal to 4x squared, outside minus 14x, inside plus 14x. Ooh, there you see, that's where I was saying yes, yes, and then minus 49. But look, these cancel, so you get 4x squared minus 49. And that is a beautiful thing. Okay, let's do one last one. So what if you have another term outside of the two binomials? That should be no issue. 3r plus 2, 3r minus 2. You can already see that this is actually going to be 9r squared minus 4, but let's work through it. Okay, so I'm going to keep the r squared outside for now, and then I'm going to multiply that by 9r squared plus 6r minus 6r minus 4. Those cancel. You get r squared, 9r squared minus 4. And then that ends up being 9r to the 4th minus 4r squared. You pass the r squared in at the end if you want to. So this was actually one of the special products that works out really nicely. And I'll go through a few of those right now. Well, actually, we'll write out the form of them, and then we'll go through some examples. All right. Special products. Okay, the first one was what we saw earlier. So x plus y. X plus y, x minus y. What will this work out to? it will have the form x squared minus y squared, which we saw earlier, x plus y squared. This will end up having the form x squared plus 2xy plus y squared. And then this, oh, why do I keep writing forward? Looks like y in my brain. X minus y squared equals x squared minus 2xy plus y squared. So, and if you work, these are just definitions so you can see the form, and then we'll work through a few more examples. So let's do this one, 3p plus 11, 3p minus 11, and this will be this form right here, x plus y, x minus y. So we could do the shortcut and just go straight to the answer, but let's work it out. So 3p, well, sorry. Let's do the foiling necessary. 9p squared minus 33p plus 33p minus 121. So cross equals 9p squared minus 121. Whoa. Not 1,211. Okay. So you can see you could have just jumped to the answer by multiplying 3p, 3p, and 11 and negative 11. But the full math passes through this step. Okay, now we're going to do one of the second form. So 2m plus 5 squared. So let's work it out again, just so you can see that, so we can convince you that the answer will have that form. 2m plus 5, 2m plus 5 equals 4m squared plus 10m plus 10m plus 25. There you go. So that is this one. And, ooh, this should be fun. 3x minus 7y to the fourth squared equals 3x minus 7y, 3x minus 7y. There you go. That's the start. Then we go, oh, to the fourth. Forgot that. Gotta always watch the steps. Okay. 9x squared minus 21. X y to the fourth minus 21x y to the fourth plus 49 y to the fourth. So that is negative 42. 9x squared minus 42x y to the fourth plus 49 y to the fourth. Boom. Loving it. Loving it. Yeah, so that one is this one. There you go. All three. What do we have here? What do we have here? Oh, did we do it? We did it. We did all of it. That was our review of exponents and polynomials. Thank you for tuning in. You can do math too.